So previously we discussed about working principles of DC generator and DC motor and DC machines construction. Now we'll discuss about working principle of synchronous generator. See, what is the difference between DC machines and AC machines, synchronous machines? See, in DC machine, field winding placed on stator, armature winding placed on rotor. Now, just reverse it. Just reverse it in synchronous machines. Means field winding placed on rotor, armature winding placed on stator. See, here this one is field winding. This one is field winding. This one is this is armature winding. This is armature winding. So what is the difference? Simply reversed. Armature winding placed on stator and field winding placed on rotor. See, now we'll discuss about working principle of synchronous generator. Working principle of synchronous generator. See, here armature conductors are stationary. Armature conductors are stationary. Armature conductors are stationary. Suppose if you give DC supply, which type of magnetic field is developed in the field winding? Constant magnetic field, north pole, south pole, constant magnetic field. So if constant magnetic field cuts to the armature conductors, is there any EMF induced in the coil? No EMF, because both are stationary. Both are stationary. So that first, initially I will apply mechanical input to rotor of the, this is rotor shaft. See, here I will, by using prime mover, I will rotate the rotor. This is rotor, let us. What I will do? This, I will rotate the rotor by using prime mover. So this is clockwise direction. Suppose if the rotor is rotating in clockwise direction, let us see. Along with, if I give DC supply, what happen here? Magnetic field is rotating. Along with, if you rotate the rotor, what happen? This magnetic field is rotating in clockwise direction. See, initially magnetic field is here. That means this is stator, this is rotor, north pole, south pole. After, if it is rotating in clockwise, what happens? After some time, north pole is here, south pole is here. After that, north pole is here, south pole is here. Means magnetic field is also rotating. Here magnetic field is rotating. So if you rotate the rotor, magnetic field developed in the field coil also rotating. So which type of magnetic field is placed here? Rotating magnetic field. So whenever the rotating magnetic field cuts to the armature coil, what happen? EMF is induced. So what is the working principle? So whenever the rotating magnetic field cuts to the stationary armature conductors, then the EMF is induced in the coil. That EMF collected by the terminals. That EMF can be collected by the outside terminals. So what is the working principle? Whenever the rotating magnetic field cuts to the armature conductors, EMF is induced. This is the working principle of synchronous generator. See here, but condition is DC supply given after the rotor is rotating nearer to synchronous speed, not exactly synchronous speed. After rotating the rotor at nearer to synchronous speed, I will apply the DC supply. I will give the DC supply. I will give the DC supply. Clear? So this is working principle of synchronous generator. Working principle is enough. In depth, if you want to discuss, you will get little confused. Okay? Working principle is enough for BEEE students. BEEE subject, working principle is enough. So here working principle is whenever the rotating magnetic field cuts to the stationary armature conductors, EMF is induced. EMF is induced. So when you will give the DC supply, whenever the armature conductor is rotating nearer to the synchronous speed, then I will give the DC supply to the field coil so that rotor is rotating with synchronous speed. Rotor is rotating with synchronous speed. See, why it is called as synchronous machines? Why? Because rotor is always rotor is always rotates with constant speed. Rotating with constant speed. Rotating with constant speed. That is called synchronous speed. Rotating with maximum speed. So this is about synchronous machine. In both synchronous generator and synchronous motor, which is rotating with synchronous speed. That's why it is called as synchronous machine. Thank you. So you can see my notes. Already I shared the material that you can prepare.